Okay, so just a little recap on kind of more basic probability questions. So to start off with, sorry now. Okay. Right. How many arrangements can be made with the letter soldier if all the letters are taken at a time? So in this case, there are 7 letters, there are 7 positions, it's your 7 factorial. Okay, alternatively, you can draw out your 7 spaces. What's that? 3, 6, and go 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, which is the same as 7 factorial. How many of these arrangements begin with the letter SO in that order? And that word there, that phrase at the end of that sentence there, in that order, is really important because this now means that I have SO and it doesn't, there's only one option. Okay. Because I can't have, if I didn't have in that order, I could have SO or OS, but because it's specifically in that order, I can only have it in one direction. So now I have how many of these arrangements begin with the letter SO. I'm grouping this as one set of letters. Okay, so if I group the S and the O, I then have, we'll say 1, 2, 3, 4, 5, 6 spaces left to go. Okay, now it has to begin with SO, so there are only one options for the beginning. There are 5 more options, and then I have times 5, times 4, times 3, times 2, times 1. Okay, or you could say it's 1 times 5 factorial. Okay, either way, you'll have 120. You then have how many of these arrangements begin and end with a consonant. Okay, so if it is to begin with a consonant, there are 4 consonants. There are S, L, D, and OR, so there are 4 of them. I again have 7 letters. 1, 2, 3, 4, 5, 6, 7. If it begins with a consonant, one of those consonants is gone. I have 3 left to put at the end. So one of those 3 has to be at the end. I then have 5 letters of the word soldier left. I've used one at the start and one at the end. Of those 5, they can be placed in any order whatsoever. Okay, or you could say 4 times 5 factorial times 3. Either or, you will get 1440. Okay, so that is your permutations. Okay, this one we kind of had a look at similar ones to this before the midterm, but I just want to clear a few things up on it. 2 different numbers are chosen. Okay, so if you have chosen, you're kind of going to be thinking about your combinations. Okay, which is your N, choose, or button on your calculator. From the digits 1, 2, 3, 4, 5. So first of all, if 2 are chosen from the 5, before I even go in to answer any of these questions, if there are 2 chosen from 5, it means I have 5, choose 2. That means there must be 10 choices available. Okay. A is the event that the sum of the 2 numbers is even. Okay. There are 2 ways that you can do this. So the probability of A, the sum of the 2 numbers are even. So you can either have, you can add 2 even numbers, or you can add 2 odd numbers. They're the only ways to get that. Okay, 2 even numbers, I have 2. I have to choose both of them. So that's only one option. Or I can think about what my one option is, which would be to use the 2 and the 4. And the order doesn't matter because I'm only asked for the sum of any 2 numbers is odd. So it's the same adding 2 to 4 or 4 to 2. Adding 2 numbers is even. So 2 numbers then being odd, I have 3 odd numbers. I would have to choose any two of them. So 3 choose 2 is 3. Or alternatively, I could list them out. I could say I need 2 odd numbers. So I need it to be 1 and 3, 1 and 5, or 3 and 5. Okay. And again, the order doesn't matter. So they're my only 3 combinations. Either I can list or I can use my combinations. Okay. Either way, I have or. So 1 plus 3 is 4. I have 1 choice plus 3 choices. I still have 4 choices here. Okay, so I'm asked for the probability this time, not the number of choices. So 4 is just the number of outcomes. Okay, the probability of that happening is 4 over 10. Okay. The probability then of B. Okay, so the probability of B would be to get an odd number. And the only option to get an odd number is to have 1 even number plus 1 odd number. Okay, I have to have an even number added to an odd number. So again, I have 2 choices of doing this. The chances of getting 1 even, I have 2 even numbers, choose 1, and I need both of them to happen. And 1 odd number, I have 3 of them, choose 1. Okay, that will get me 6 outcomes, which again is 6 out of the total of 10 possible outcomes that I can get. Now, alternatively, you could have gone and thought about this without using your combinations, and you could have said, you could have listed them. So you could have said you need 1 plus 2, or 1 plus 4, or 2 plus 3, or 2 plus 5, or 3 plus 4, or 5 plus 4. Okay, and again, you still have your 6 outcomes out of 10. Okay. Okay, are A and B mutually exclusive? Okay, they are mutually exclusive. Okay, it is not possible to both be even and odd. Okay, so I can't choose numbers. I can't choose 2 numbers to add together that will both be even and odd. Therefore, they are mutually exclusive. To calculate the probability of A union B, remember you have 2 formulas. You have a formula if they are mutually exclusive, and you have a formula if they are not mutually exclusive. They are in your PowerPoint, so have a look. So the probability of A union B is the probability of A plus the probability of B, which is 2 over 5 plus 3 over 5, which makes sense in this case to be 1. So either they add up to even numbers or they add up to odd numbers. There is no other alternative. Part V requires a little bit more thinking. If C is the event that one of the chosen numbers is 2, are A and B mutually exclusive? Okay, so in this case, we have that A and C are not mutually exclusive. Okay, as there is at least one outcome, okay, that belong to both A and C. Okay, so in this case, A and C mutually exclusive, the answer would be no. Okay, because it sees that one of the chosen outcomes is 2. Can it also be even? And it can. Okay, so I can actually get, it can be even and use the number 2. Okay. Okay, the next question here, I think this is the last one for this. An EU committee consists of 5 French, 3 Polish and 4 Italian members. 3 of these people are to be selected at random. A is the event that all 3 are the same nationality. B is the event that one of each nationality is picked. So First of all, 3 people are chosen. Okay, chosen or selected. Again, another word that you'll have to use your combinations. Okay, so there are 5 and 3 is 8 and 4. There are 12 in total. Okay, so I have 12. I need to choose 3 out of that 12. So I have, go to my calculator, 12 choose 3. There are 220 possible choices. Possible in this case, selections. Random selections. Okay. The probability A that they are all the same nationality has to be either that they are all French or all Polish or all Italian. So that means that out of the 5 French people, 3 of them are chosen, or, so plus, out of the 3 Polish, all 3 of them are chosen, or out of the 4 Italians, all 3 of them are chosen. So we'll have 10 plus 1 plus 4 gives me 15 out of the total 220. Okay, which will give you 3 out of 44 if you simplify it. Okay. Remember, this is probability. So 15 was just the number of outcomes, and the total number of outcomes was your 220. So the probability of B then, that there is 1 from each of the nationalities. That means there would have to be 1 French. So there were 5 French, choose 1. And 1 Polish. So we have 3, choose 1. And 1 Italian. So we have 4, choose only one of them. So I've got 5, and means multiply, 3 and 4. So I've got 60 outcomes here, 60 out of a total of 220. Okay, which will give me 3 out of 11. Are A and B mutually exclusive? They are, okay, because you cannot get both 3 from, you can't have both 3 French people and 1 from each country. So if only 3 people are selected, then they can either be part of probability A or part of probability B. Then it says, IV, calculate the probability that the 3 people chosen are either the same nationality, so probability A, or one of each of 3 nationalities, which was probability B. Okay, so if they are, calculate the probability that the 3 people chosen are either, so they're one or the other, so that means they have to be in the set. The probability of A union B, because they have to be within that set. Okay, and I know if they are mutually exclusive events that I don't have the intersection, so it's simply just 3 over 44 plus 3 over 11 is equal to 15 over 44. Okay, remember that is for mutually exclusive. If they were not mutually exclusive, it would be probability of A plus the probability of B minus the probability of A intersection B. Okay,